Today we present our project, which would be an intelligent tutoring system for LEU students. Our project basically leverages advanced software engineering principles in order to create um, a very advanced, a very personalized educational platform that is dedicated for all faculty of LAU and all students without discrimination accordingly. Now, with that said, let's delve into its intricate features and technical foundations.
Okay, now we're going to start with the overview of our project, which is the Intelligent Tutoring System. This system aims to mimic a human tutor, providing students with an adaptive and interactive platform. The objective here is to make learning not only personalized but also more engaging. Our target audience includes students across various majors, ensuring that the system addresses diverse academic needs. From introductory courses to specialized disciplines, ITS supports both general and tailored content. Additionally, the goal of ITS is clear: to enhance student engagement, understanding, and retention. Metrics from pilot implementations show a 60% improvement in test scores and a 95% satisfaction rate among active users. Now let's dive into the core features that make ITS a game changer. First of all, we have the interactive tutorials. These dynamically engage students by adapting to their pace and understanding. For example, slower learners are guided with additional resources, while advanced students receive challenges to keep them engaged. This approach has reduced dropout rates by 18%. Secondly, we have the adaptive learning, which is powered by machine learning models trained on over 10,000 students' interactions. The system tailors content to meet individual needs, ensuring every learner's success. Then we have the peer collaboration and gamification. It features like group discussions and leaderboards, foster community and motivation. Research shows these elements boost learning retention by 30%. Then we have the real-time analytics. Uh, Educators benefit from actionable insights on student progress. For instance, heat maps and performance charts highlight areas where students struggle, improving intervention accuracy by 20%. Last, we have the seamless integration. The system integrates with existing platforms like Blackboard, offering a unified learning experience through single sign on. With a 24/7 AI driven support, students can access help whenever needed, ensuring no one is left behind.
As for the ITS system implementation features, we noticed that our ITS has an integration with LEU platforms, such as its cross-platform integration with Blackboard, allowing for constant updates and constant versatility and scalability. In terms of continuous content updates, we have that because our ITS is also dovetailed with Blackboard. So as faculty members download lectures on Blackboard, they would also that would also be commemorated onto our ITS. A stable internet connection is always required for the for the fast and advanced running of our ITS. And in terms of cross-platform compatibility, we notice that our ITS is compatible on three different types of platforms. We're talking on mobile, on desktop, and on laptop accordingly. In terms of the comprehensive technology stack overview, we realized that the programming languages utilized within our ITS are both Python and JavaScript, ensuring a very advanced, versatile, scalable, executable website. In terms of our core libraries that were utilized in our backend, we use Node.js for the server-side development in order to enhance performance and scalability accordingly. In terms of front-end frameworks, we use the React.js in order to allow the flowing of a dynamic front end accordingly. And in terms of back end frameworks, we used Express.js to also enable building APIs and web applications that are very robust. In terms of our database choice, we were focusing on efficiency and allowing CRUD operations to, which is basically create, read, update, and delete operations. So we needed CRUD operations that are very fast and that are very efficient. So we kind of tended towards the use of MongoDB. And in terms of testing tools that were done in order to test our software, we used VidTest, Jest, Cypress, and Artillery accordingly.
Now, to understand how ITS operates, we need to look at its architecture. It's built on three key layers. First, we have the presentation layer. This is the face of ITS, serving as the user interface where students interact with the system. It hosts all interactive elements and has been optimized for engagement, leading to a 40% increase in interaction rates. We use React.js and Redux to build a seamless and responsive interface. The application layer, this is where the magic happens. It houses the AI bot, adaptive learning logic, and educational content. For example, the bot handles approximately 1,000 queries daily, analyzing students' behavior to recommend tailored learning path. Algorithms like reinforcement learning and natural language processing drive this functionality. The data layer finally is the manages the user data, tracks progress, and oversees content management. Built on no SQL databases, it ensures real-time analytics with the minimal latency. This layer supports the system's ability to scale efficiently. On the most significant updates to ITS is the presentation layer designed to improve user experience. First, for the front-end framework update, by transitioning to React.js, we ensured scalability and responsiveness. The virtual DOM allows for updates that are 20% faster than traditional frameworks. For the user feedback mechanism, we have interacted tools for users to share their feedback. This feature has already increased engagement metrics by 15%, highlighting its importance. Then we have also the visual aesthetic enhancements, a redesigned interface tested through A/B experiments resulted in a 25% boost in user satisfaction. And lastly, the intuitive navigation with streamlined menus and pathways. Students can now accomplish tasks 10 seconds faster on average. These changes emphasize how design can directly impact usability.
In terms of our In terms of our enhancements in the application layer, we notice that we have backend reinforced backend implementations, which come in the form of the utilization of Express.js and Node.js for a more robust backend, hence enhancing API performance and enhancing its scalability accordingly. In terms of optimized APIs, we find that APIs have been enhanced, refined for improved performance accordingly. We also move to another feature in the application layer that has been enhanced, which is streamlined user interface, such that the user interface has been simplified, being overall clear and comprehensive for every user that may come across the ITS accordingly. As for a fourth enhancement that we've added ourselves, we find that we have a quick quiz access, so users can now access quizzes quickly, hence enhancing engagement and allowing peer assessment to occur in a more automated, more developed manner. Moving on to the comprehensive data layer management, we find that we have a lot of different aspects that we could be talking about. We begin with the user results preservation, such that all results are systematically displayed, hence ensuring that data is private, it's integral, and it's accessible for the user that has the data stored to his account accordingly. The second feature would be content change tracking. That means that changes to content are tracked, and there is a history that remains for display for the account at handling accordingly. Effective data management via utilizing MongoDB, we were able to allow for efficient handling of complex data accordingly within the ITS. We have course information storage. The ITS is capable of storing as much information as is presented for every single course, from lectures to PDFs to classes that are recorded, so on and so forth. This allows for seamless updates and retrieval, and also engagement from students accordingly. We move on to the final aspect of the data layer management, which would be, Maha, the previous slide, please. Which would be the MongoDB schema integration. The system is integrated with MongoDB, hence optimizing data management accordingly. You may proceed. As for coding standards and best practices, me and my partner were very cautious of abiding by coding standards in order to allow the software LCA, the LCA of the ITS, to move in a very convenient manner. So with that said, in terms of coding, we were able to abide by code quality. Since we utilize TypeScript for a robust typing system, we were able to ensure that aspect. We were very aware of security considerations, such that we were able to integrate several security practices accordingly. And access control, which is basically the implementation of access control mechanisms for user roles, hence enhancing security for users and ensuring that their data could not be seen by another anonymous individual that is trying to hack their account at that matter, or is trying to seamlessly be taking away some of its data, downloading it for themselves. In terms of modular structure, apologies, we adopted a modular approach, hence promoting easy readability and maintainability of the code base. We also had environment variables, which we actually were able to use securely managed sensitive credentials. And in terms of input validation, the ITS employs input validation techniques to prevent any injection attacks or any breach of data, hence ensuring data integrity accordingly.
Now we're going to discuss our comprehensive testing strategies, which ensure the reliability and quality of the system. First, we have the unit testing. We utilized Vitest for the front end and Jest for the back end to verify that individual components function correctly. This ensures that every model performs as expected in isolation. For the integration testing, we used Supertest. We automated API calls to validate the interactions between components. For example, we tested how the sign-up model communicates with the backend to create a new user. For the system testing, we conducted it with Cypress. Our system level tests simulate real world user interactions such as sign up flows, course navigation, and error handling. These end to end tests help identify any potential bottlenecks in the system. This three layered approach ensures that our system is robust, scalable, and user friendly, with each layer of testing addressing a specific aspect of functionality.